Good morning. We are on Probability and Data Management, Lesson 5. It's about outliers, which I talked to you a little bit about yesterday. And this is the last lesson before the first quiz. So I'll put together a little review video of what you'll need to do or need to know for the quiz so that you can watch that before you do it. Okay. So an outlier is a piece of data that is way outside of, normally your data is fairly close together. An outlier is either super low or super high. It's something that kind of ruins your data set because it greatly affects the mean, it greatly affects the range. So when you collect data, if you get an outlier like that, often the best thing to do is not include it in the data if you were actually doing a study. For our purposes, because you're getting data given to you, you just need to see what having an outlier in your data does. You just have to understand why having an outlier there changes your results. Kylie, can you get the dog, please? Okay, so it starts out with an investigation. Investigation 1. Which value in a set affects the range the most? Find the range of the set 2, 3, 5, and 202. Wow. Obviously, there's one here that doesn't belong, right? So if you remember the range, Kylie, dog. If you remember how to find the range, you find the highest value piece of data and the lowest value, and you subtract. So in this case, it'd be 200 minus 2, so the range is 200, which is huge. Now, they want you to remove one value from the set and find the range of the new set. Okay, so the new set, the first one they give you is 3, 5, 202. So they got rid of 2 in this set. So the range is now 202 minus 3, which is 199. Very similar, right? Now you're going to put the 2 back in and get rid of the 3. So now it's going to be 202 minus 2 is 200. Now we're going to put the 3 back in and get rid of the 5. Well, it's still 202 minus 2 equals 200. Okay? So we did that for all 3. Which value affects the range the most? Well, clearly 202 affects the range the most. Because if you had a set without this 202, your range would be like 3. 5 minus 2 is 3, right? So, oh yeah, I forgot to, and then we had to do one where we left 202 out. So that would be, if we left 202 out, it'd be 5 minus 2 is 3. So the range is only 3 when you get rid of that outlier. Okay? So now you've got C, mark the data values on the line number below. So you've got a line here and it goes all the way from 0 to 210 or something. Yeah, 210. And you just have to make a mark. So our set was 2, 3, 5, 202. So like 2, 3, 5 are all going to be down there and 202 is going to be there. Right? So you can see the majority of the data is all bunched together, which is what we like to see. We don't like to see these. Okay, part D, repeat parts B and C with this set. So what they want you to do is give you a new set. The new set is 2, 52, 102, 152, 202. Now, when I was writing this out, I was looking at it as like 2 to 52 is 50, 52 to 102 is 50, 152 is 50, to 252 or 202 is 50. So there's not really an outlier in this data because everything is equally spaced out. It's just that none of it is bunched together. But what they want you to do is repeat the same process. So you're going to go find the original range. 202 minus 2 is 200. Now I'm going to get rid of 2. So it's 202 minus 52. equals 150. Now I'm going to add this back in and take out this. So we're back to 202 minus 2. Now I'm going to add this back in and get rid of this. And I'm back to 202 minus 2. 202 minus 2. Now I'm going to get rid of 202. So I'm going to end up with 152 minus 2 is 150. So the biggest range is when you include 2 and 252. Or 202. That's a range of 200. The others are all ranges of 150. So I suppose you could argue that 2 would be the outlier. Mark those on the number line the same way. Find where they would go. Don't go crazy trying to divide each little section into 10. If it's a 2, just make a line closer to the, you know, if it's 12, make a line close to 10. It doesn't have to be that accurate. Okay, how does removing the value that most affects the range change the range? Well, clearly when we were dealing with, it was clearer in the first example, but when you had 202 minus 2 and the range was 200, and then we got rid of the 202 and our range was only 5 minus 2 and it was 3, having an outlier makes your range go through the roof. You have this crazy range of data when you have an outlier. So it makes the range much smaller when you get rid of the outlier. Okay, so they're talking about outliers in question 1. All right, question 1, for each set below, create a stem and leaf plot of the data, identify the outlier. I will only do the first one for you, then you guys can do the rest. Okay, stem and leaf. Stem, leaf. 23, 25, 65, 25, 37, 761, 41. Okay, so I got to redo this so it's in good copy, right? So 2, 3, 4, 6, 2, 3, 4, 6, and 76, right? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Good. Now, with my 2, I have 3, 5, 5. With my 3, I have 7. With my 4, I have 1. With my 6, I have 5. And with my 76, I have 1. Okay. So an outlier is always going to either be the very first number or the very last. It obviously can't be in the middle, or it would be in the middle of the data. So you have to check, is 23 way far away from all the other data, or is 761 far away from all the other data? Clearly, 761 is far away. Okay, so you have to make a stem and leaf plot, put it into good copy with all the numbers in the correct order, and then circle your outlier. Okay, pause the video, go do A, B, and C. How can a stem and leaf plot help you identify an outlier? Well, as I said, it's either going to be the very first number or the very last number. So you've only got 2 choices, so that narrows it down a lot. Okay, number 2. This set does not have an outlier. 2, 3, 100, 101. No, that's not right. 201, 202. Okay? Why is none of these an outlier? Well, you can see we've got 2 pieces of data closely bunched together at the low end, and we've got 2 pieces of data close together at the other end. Then we've got one in the middle. An outlier can never be in the middle. You would never use it to find the range. So if this was just 2, yes, we'd have an outlier. If this was just 202, yes, we'd have an outlier. But because there's 2 numbers at each end, neither of them is an outlier. Okay? Okay, investigation 2. Does adding an outlier affect the mode? Well, think about this. What is the mode? The mode is the most frequently occurring number. Can an outlier occur more than once? Suppose it's possible that you could have a set of data that was all bunched together and then 500 3 times. But that would be really unusual, okay? So let's do the investigation, see what happens. What is the mode of the set 110, 115, 110, 113, and 114? Well, there's only one number that repeats. So that's the mode. Does the set have an outlier? No, everything is pretty tightly bunched. So no, it doesn't have an outlier. Now, they want you to add the outlier 200 to our set. The new set is 110, 115, 110, 113, 114, 200. What is the mode? The mode is still 110. Even though we added the outlier, it's not more common than 110, so that is still the mode. Now add the outlier 1. So you've got 1, 110, 115, 110, 113, 114. What is the mode? It's still 110. We've only added one number, so there's no competition for the mode. Does an outlier change the mode of the set? No, it does not. Unless it became the new mode, then it would, but that would, I don't even know that you'd ever see it. Okay, investigation 3. Consider the set 2, 3, 4, 5, 76. Circle the outlier. Well, clearly one of these doesn't belong. You guys circle it. Find the mean and the median. Okay, so mean. You remember how to find the mean? Add them up, then divide. So 2 and 3 is 5, 5 and 5 is 10, 14, plus the 6 is 20, and 7 is 90. So I added them all up, and I get 90. And 1, 2, 3, 4, 5, I got to divide by 5, and 90 divided by 5 is 18. Okay? So mean is 18. Median, now this is going to come up on your test, so you have to remember this. If you're making yourself a study sheet, make sure you write this down. When you do the median, it must be in order. From largest to smallest or smallest to largest, it doesn't matter, but the numbers must go in order or you won't get the correct median. Okay, so 2, 3, 4, 5, 76. It's all in order. Median is the middle number. Start at the ends, go in 1, go in 1. Our median is 4. So both of these things are meant to find the average. They do it in different ways. But look at the difference. 18 here, 4 here. Your measures of central tendency, mean, median, mode, in good data should all be close together. 18 is way too far from 4, so that means we've got an outlier somewhere. Write the set without the outlier. All right, I can do that. Goodbye, outlier. Find the mean and median of the new set. Okay, remember, mean, add them, divide them. 2 and 3 is 5, 5 and 5 is 10, and 4 is 14. Divided by 4, 1, 2, 3, 4. 14 divided by 4 is 3.5. Okay? The median, they're in order, 2, 3, 4, 5, so I start at the end and I go in. Now I have 2 things in the middle. What's halfway between 3 and 4? 3.5. This is good data. We've got a mean and a median, which happen to be identical, but I'd be happy if they were also just close. Okay, which value changed more by the removal of the outlier, the mean or the median? Well, in our original one, I think our mean was 18 and our median was 4. So it went from 3.5 to 18 and 3.5 to 4. So the mean was much more greatly affected by the outlier than the median. Choose any other value in the set and write the set without it. Okay. So our original set was 2, 3, 4, 5, 76. So let's get rid of 2. I wrote the set without it. Find the mean and the median of the new set. All right, 3 and 4 is 7, 12, 18, 88. 88 divided by 4 is 22. And the median, okay, I'm in order. I walk in. It's halfway between 4 and 5, so that's 4 and 4.5. Repeat the investigation with these sets. Okay, so you're going to do the exact same thing. They're giving you a bunch of sets of data. You're just going to find the mean and the median and then get rid of one of the values. Okay? I chose to get rid of the outlier. I don't know if they specifically say get rid of the outlier, but that's what I did. If you want to get rid of the outlier and then do it again by getting rid of one of the other ones, that's totally up to you. The important thing you understand is that the outlier affects the mean greatly. Okay? So I will do the first one with you. 78, 77, 12, 69, 74. Now, I'm going to give you a hint. To be ready for your quiz, you should have noticed this is not in order. Okay? I would rewrite it before I do anything else to get it in proper order. So we've got 12, 69, 74, 12, 69, 74, 77, 78. So I would only work with it in proper order. All right, so to add it up, I've got 777, that's 210. And 6 is 270, and 1 is 280. Now, that's 290, 299, 303, 310. So 310 divided by 1, 2, 3, 4, 5 is 62. And I did that so quickly because I know that there's 20 in each 100, so I went 20, 40, 60, and I know 10 is 2. Okay, so the mean is 62. The median, start at my ends, walk in, the median is 74. Okay? Now, if I get rid of my outlier, which is the 12, because everything else is, between 60 and 80, let's try again. So 777 is 210, and 6 is 270, 279, 283, 290, 298. So 298 divided by 1, 2, 3, 4. I gotta work it out over here. 4 into 29 goes 7 times, which is 28. 1, 18 is 4.5. So 74.5. That seems totally reasonable. Looking at my data, I would see that if I had all my beads on a stick, that it makes sense that I could take some off of here and give them to those. 74.5 makes sense. And huge difference from 62, which was lower than 1, 2, 3, 4 of our 5 pieces of data. See how much effect an outlier has? It's like a stone around the neck of your data, dragging it down. And on the other end, if it's on this end, it's like a rubber band pulling it up. Okay, so 74.5 is your mean. And your median, okay, so where are we? We're just with these ones. So I take a step in, and I need what's in the middle of 74 and 77. Well, I know there's 3 between 74 and 77, and half of 3 is 1.5, so that makes this 75.5 is the median. Look how nice and tight our mean and our median is, 74.5 and 75.5. That means our data's good, and it makes sense with what's up here, okay? So you're gonna go repeat that with the other, oh, you've only got one to do. What do you know? What affects the mean? So you go do that, come back. What affects the mean and the median more? The removal of the outlier or the removal of another value? Well, I've shown it to you a bunch of times. You should know the answer right away. Removing the outlier makes a huge difference. Removing another piece of data does not make a huge difference. Okay, the set 2, 3, 4, 5 does not have an outlier. 2, 3, 4, 5. No outlier. If you add 100 as a new data value, what will be affected more, the mean or the median? Well, we've talked about this. The mean is always affected by the outlier. So let's figure it out just to be sure. 105, 110, 114 it adds up to, divided by 1, 2, 3, 4, 5. 114 divided by 5 is 22.8. And so our mean is 22.8. Well, look at our data set. It doesn't match with it at all. This is wreaking havoc with our data. Mean, our median. Go to the ends, walk in. So this is our mean. Our median is 4. Look at the difference. The measures of central tendency should be tightly bunched. 4 and 22.8 are not tightly bunched. Okay? Now they want you to get rid of, let's get rid of it and see what would happen without the outlier. Okay? So we're going to get rid of that. 5 and 4 is 9, and 3 is 12, and 2 is 14. 14 divided by 1, 2, 3, 4 is 3.5. That's the mean. The median, walk in, it's halfway between 3 and 4. So the median is also 3.5. This is good data. It's bunched together. So yes, the outlier affected hugely. Now the median was 4 here and 3.5 here. That's not a huge change. But the mean was 22.8 with the outlier and only 3.5 without it. So the mean was changed much more than the median. Okay? Number 4, find the outlier in each data set. Just find the piece of data that doesn't match with the rest of them, that's farther away. Okay? Circle the outliers. Go do that. B, in which of the above situations is the outlier likely a mistake in the data? So I could actually come up with scenarios for a bunch of these. But ages of the members of the Bridge Club in Golden Age retirement residence. So the bridge players in the retirement residence, you have to assume that everybody's old who lives there because young people don't live in retirement residences. But there is a 7-year-old in the data set. Now, I think that's a possible outlier because maybe somebody's grandkid comes and plays with them. You don't know, right? But it would also make sense if that 7, if they had like left off the other number and it was actually supposed to be 75. So that could be an outlier. The yearly salaries of permanent employees in a company, the B one, you've got 25,000, 35,000, 300, and 45,000. Now, it says the yearly salaries. Do you think that somebody makes $300 a year when everybody else is making between 25 and 45,000? Like, did they only work 1 week? It makes no sense that they would only make $300 a year. So I think my opinion is that would be the outlier. Unless, like I said, this person only worked 1 week out of the year, but that's hardly called a yearly salary. So I think that's the outlier. Hourly rate of contract workers in a company. You could also argue this, but here would be my answer. They're all making between $17.50 and $45 an hour, but one person makes $300 an hour. Is it possible that the company hired a really expensive contractor who had a very special skill and that's what he charged? Yep, absolutely. So yes, it's a lot of money, but I think it does happen. So I think that the outlier is B, but you could argue any of them. In which of the above situations is the outlier likely a mistake? Oh, there you go. I've been working on that one instead of the other one. I already explained it to you. That's the one that I've just been talking about. Okay, number 5, Katie's math test scores, which are out of 20. 16, 17, it's terrible 6. 16, 17, 17, 5, 19, 18, 17, 20, 19. Okay. What is the outlier in this set? Well, it would help us if we put it in order, right? So lowest number is 5. Then that's that one. Then it looks like 16. It's that one. Then 1, 2, 3 17s. 1, 2, 3 17s. An 18. 2 19s. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we got them all. Okay, remember the outlier is going to be the very first or the very last. So do we think that 20 is not like the other scores, or do we think that 5 is not like the other scores? I'm saying 5 is not like the other scores. So that is the outlier. In part B, it asks, when the teacher finds the average for her report card, should he include the outlier? Lots of you have bombed a test, and I chose to throw it away and let you redo it because I don't think it reflects your actual ability. I think maybe you had a rough day, maybe you didn't sleep, maybe you didn't prepare, which certainly has happened, but 16 to 20 is a much better gauge of her ability. If we put this in here, it doesn't ask you to do this, but just as an experiment, let's try. So 20, 30, 40, 50, 60, 70, 80, 90, 99, 108, 116, 123, 130, 137, 143, 148 is what I get off the top of my head. 1, 2, 3, oh, there was 9. 148 divided by 9. So 148 divided by 9 goes in once, which is 9, 5 left over, 9 into 58 goes 6 times, which is 54 with 4 left over. It's about 16.4. Okay, so that would make her average 16.4 if we include the outlier. If we don't include the outlier, we'd have 148 take away 5, so that'd be 143 divided by 8 because we're getting rid of that score, right? So let's try that. 143 divided by 8. 8 goes into 14 one times with 6 left over. 3 goes in 7 times with 7 left over. So it's about, I don't know, 17.8 or so. So if we get rid of the outlier, her average is 17.8. If we have the outlier, see how it drags it down to 16.4. If these were your marks, you would not want that included because that takes you down about 8%. Like if we're looking at 16.4 out of 20, right? Each mark is worth 5, right? So here she's missing 15. This is about an 80. She's only missing, this is closer to a 90. So you don't want an outlier unless you did amazing on a test. And then if you did amazing on a test, it would pick your average up. And you would want that outlier included, which is an interesting argument. If you're going to include an outlier that drags a mark down because it doesn't represent your abilities accurately, should you include an outlier that pulls your mark up? Because it really doesn't affect your abilities either. But I'll tell you, as a teacher, I love seeing you guys do good. So when you get a high mark, I am absolutely including it. When you get a low mark, we're going to fix it. Okay, number 6, last question. One day, a scene from a movie is filmed outside of 10 Daffodil Street. At 8 Daffodil Street, there's a small coffee shop, and the daily sales at the coffee shop are 1,000 times what they normally are. So if they normally do $500 in a day in a coffee shop, now it's 1,000 times greater. So it's going to be 500,000. They're going to do $500,000 in one day. That's crazy, right? Now, do you get where we're going with this data? There's going to be an outlier. Does the set of the daily sales for the year contain an outlier? So they're going to have a calendar and they're going to have their sales on every day of the year. One of those sales is going to be, one of those days is going to be $500,000. So is that, well, I don't know, it's $500,000, but it's 1,000 times what it should be, right? So, is there an outlier? Yes. To keep track of sales, the coffee shop finds the average daily sales for the year. So they're going to take all their sales for 300 and some odd days of the year, because we have to assume they're closed Christmas and stuff like that. So they're going to, for 300 and some odd days, they're going to have their sales. They're going to add them all up. They're going to divide them by how many days they were open, right? Should the owner of the shop include the outlier in the calculation? Well, it depends on what you want to do with it, is my feeling. So if you want to know what your total sales were for that year, yes, include the outlier. However, remember, that outlier is going to drag your average way up. So it's going to affect the average daily sales hugely. It's not going to reflect. It would be so depressing to say, well, if I included the outlier, well, my average daily sales last year were $10,000 a day, but now they're only $500. So that would be like comparing the two isn't valuable because that was a one-off. It's not like they're going to film movies at 10 Daffodil Street every year, right? Movies are, and I mean, best case scenario, it's an incredible hit and they make them, they're only going to make it once a year for how many years? Like how many sequels could there be? So it's really not a valuable piece of data. I think you have to look at it as a wonderful gift you got that one time. So I say no, you don't include the outlier. The owner decides to sell the store. She includes the average daily sales in an advertisement. Should she include the outlier in the calculation of the average? So, imagine that you're somebody who's looking to buy a store and they post the daily average sales and they say, you know, our daily sales were $5,000 or something, if you include the outlier. And you're like, it's a very profitable business, this might be worth buying, I think I should invest in it. And then you get the daily books and find out that, no, there's only been one day that they've had huge sales like that. The rest of the days it's like $500. So as somebody wanting to purchase a business, I would feel really misled if you showed me your average daily sales with the outlier, and I would walk away from the deal. I would not want to deal with somebody who would try to manipulate the data like that. Now, from her point of view, if somebody isn't as on the ball as me and thinks, yeah, that's a really profitable business, her selling it could get more for her business. So I guess the person selling the business has a decision to make about whether she's greedy or honest. Because I feel like if you cheat the news seller, you could find yourself in court. So I don't think she should include the data. Okay? That's it for today. We'll see you tomorrow.